All right, 7.2, properties of rational exponents. The properties of rational exponents, the only thing you need to know are the exact same rules as whole numbers, as integers. So as what we did in chapter 6, on 6.1, those 9 rules or so that we had at the very, very beginning. Those are the exact same rules as rational exponents. You have to have like bases. If you're multiplying, you add them. If you're dividing, you subtract. If you have a power to power, you multiply. All the rules stay exactly the same. So let's just do some examples. If I have 6 to the 1/2 times 6 to the 1/3, the bases are alike, so I add my exponents. So that gives me 6 to the 5/6. Leave it, you're done. There's nothing else you can do. 27 to the 1/3 times 6 to the 1/4 squared. 27 to the 1/3 is 27 to the 2/3, and 6 to the 1/2. Now, this I could possibly do something with, and I need to check it. The cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. I can simplify it. I have to simplify it. Over here, there's no 6th root of 6 to the 5th, because 2 and 3 are the only things that make it up, and you're never going to have 6 of them, so I don't have to continue that. Here I have to consider, here's the square root of 6, because 2 and 1 can't simplify the square root of 2. There's my answer. These are different bases. It's like saying x and y. You cannot combine 9 and 6. You'll leave it alone. 4 cubed, 2 cubed to the negative 1/3. Well, that's, if I distribute here, that's 4 to the negative 1, 2 to the negative 1, which is 1/4 times 1/2, which is 1/8. 6 divided by 6 to the 3/4. Bases are alike, so I get to subtract. 1 minus 3/4 is 1/4, and the 4th root of 6 can't do anything with. 18 to the 1/4 and 9 to the 1/4 cubed. This I can reduce. 9, because of these are the same, 1/4, 1/4, I can reduce this to 2 to the 1/4. This did not change, because this is actually the 4th root, and this is the 4th root, so I can do like radicals. So same idea here. So this is 2 to the 1/4 cubed, so it's 2 to the 3/4. When I'm looking at radicals, the indexes have to be alike. If they're not the same, you can't do it. So if I have the cube root of 25 times the cube root of 5, I can combine them to the cube root of 25 times 5. Well, 25 is 5 and 5. Therefore, I have 3 of them, and my solution is 5. Cube root of 32, cube root of 4. The indexes are alike, much like up here on this one, because the 4 is the index, because it's in the denominator. Index is alike, I can reduce it. Cube root of 8 is 2. We always want to put everything into the simplest form. So if I have 4th root of 64, that's really 2 4th root of 4, because 64 is 2, 2, 2, 1, 2, 3, 4, 5, 6 of them. So that's the 4 that came out, and that's what's left over. However, there's a simplification here. I can rewrite 4. I can rewrite it as 2 squared. Well, if I can do that, then I can also say in over out. Well, that reduces to 2 times 2.5, which is 2 radical 2. Definitely go back over this problem and make sure you understand how to rewrite things so that you can simplify the parts. So let's look at another one. If I have the 4th root of 7 over 8, well, that's the 4th root of 7 over the 4th root of 8. Well, 8 has 3 2's. I need 4 of something, and I can't have radicals in the denominator. So I'm going to multiply by one more 2, so that makes 4. So that I get the 4th root of 14, and now that I have 4 of them, it gives me a whole number. Okay, let's see. 5 times 4 to the 3/4 minus 3 times 4 to the 3/4. This is junk that is exactly the same junk. It's like saying 5x minus 3x. So I got 2 of that junk. But 4 is related to 2. 4 is really 2 squared. So that means I have 2, and then I have 2 to the 6/4. Now, put all of this together. 1 6/4 is 10/4, which is 5/2. Cube root of 81 minus the cube root of 3. As it is, I can't do anything with it. But 81 is made of 3, 3, 3, and 3. I can pull a 3 out, so 1's left over. 3 minus 1 is 2. And the only way you get better at these is just to do them. Do them over and over and over and over again. So let's look at variables. Variables are the same rules as numbers, but easier. You divide the index into the exponent. Whole number comes out. Remainder stays in. So let's see what that would look like. Cube root of 27 z9. Well, we know the cube root of 27 is 3. So then I take the index into the exponent. 3 goes into 9 3 times. And there are no leftovers. So there is no radical. 16g4h squared all to the 1/2. Well, that's the square root because that's what 1/2 means. 16g4h2. So square root of 16, 4. 2 goes into 4 2 times with nothing left over. 2 goes into 2 1 time with nothing left over. 18 rs 2/3 divided by 6r 1/4 t minus 3. Well, 18 and 6 is 3. R 1 on top 1/4 on the bottom. Bases are alike. You subtract your exponents, so r 3/4. S has nothing else, so S 2/3. And T, negative, cross the line, change the sign, T cubed. Fourth root, 12, D4, E9, F14. First of all, you look at 12. 12 is made of 4 and 3, 2, 2, 3. There's not 4 of the same thing, so there ain't nothing happening with that 12. It is staying. Now we look at the D. 4 goes into 4 one time with nothing remaining. E. 4 goes into 9 2 times with 1 remaining. 4 goes into 14 3 times with 2 remaining. And you're done. Make sure you're always writing the index, because you don't want to lose silly points because you didn't put the index. Continuing with your problem. Alright, fifth root, g squared h7. So I got fifth root of g squared, fifth root of h7. Alright. 5 goes into 7. You can't have radicals in the denominator. 5 does go into 7, and that's fine. But it doesn't go in evenly. There would be a remainder of 2. And I can't have radicals in the denominator. So I need 3 more. Because once I do that, then there'll be nothing left in the denominator. Do it to top and bottom. So I get fifth root of g2h3, and now there's 10 of them. 5 goes into 10 2 times. Eight root x minus 3 root x. 8 junk minus 3 junk. As long as the radical parts are always the same, we're good. 8 minus 3 is 5, and then the junk root x. 3 gh1/4 minus 6 gh1/4. Again, as long as the junk is the same, we just combine them. Negative 3 gh1/4. 2 fourth root of 6x5 plus x fourth root of 6x. They're not alike. They do have similar parts, but they're not exactly the same, so I can't combine them. I need to consider reducing, and I can. I have 5 of something, and I only need 4, so that means I can take 1 out, because 4 goes into 5 one time, and it leaves 1 over. There's a remainder of 1. Now, I have 6x, fourth root of 6x, fourth root of 6x, and I'm adding 2x and 1x. So a total of 3x, fourth root of 6x. And there's 7 too. The best thing you do is just practice, practice, practice.